let's look at this related rates problem. Gravel is being dumped from a conveyor belt at a rate of 50 cubic feet per minute. It forms a pile in the shape of a right circular cone whose base and height are always equal. Okay, so I've got my conveyor belt and I've got gravel and it's falling into this circular cone. And it's telling me that the height of the cone is equal to the radius of the cone. Oh, height and diameter. So full distance across there. How fast is the height of the pile increasing when the pile is 13 feet high? So it's giving me the h, the height, 13. It's indicating what I want to find. How fast is the height changing? And in particular, I'm wondering with respect to time. So how is the height, dh, with respect to time? How is that changing? So let's see what else I know in the problem. Reading through again, it is falling at a rate of 50 cubic feet per minute. This is how the volume is changing. So the change in my volume with respect to time is equal to 50 cubic feet per minute. So that's the rate at which the volume of this right circular cone is increasing. And it gives me one other piece of information here that's really important. It says the base diameter and the height are always equal. So that tells me that the base diameter, two times the radius, that's my diameter, two times the radius, and the height, h, are equal. So this gives me a way of rephrasing my original equation. Let's take these doodles and kind of put some stuff together. Okay, gravel is being dumped. My pile is getting larger and larger at a rate of 50 cubic feet per minute. It tells me that the base diameter, two times the radius, and the height are equal. It wants to know the rate at which the height is increasing. What's the change in the height with respect to time, dh dt, when the pile is 13 feet high, when the height is 13. So I begin with looking at my volume equation, 1/3 pi r squared h. Now, in this problem, I want h and dt to show up. I don't want to see r. So if I look at this equation up here, it says I can replace r, dividing the 2 over, with h minus 2. This allows me to have an equation that only has the variable h in it. It's getting rid of this r for me. So the volume is equal to 1/3 pi. My r is h over 2 squared times h. Okay, so squaring that h over 2, I'm going to have an h squared over 2 times 2 is 4, h squared over 4. So I've replaced my r for an expression with only h, and I followed it through the equation. I squared it. Now I'm noticing that I have an h squared times an h. I'm going to group some things together. Multiplying the 3 and the 4, I'm going to have a 1/12 in the front. I still have a pi. I have an h squared times h. That becomes an h cubed. At this point, I take the derivative of both sides with respect to time. So on the left side, I'm looking at the change in volume with respect to time. And on the right side, that's also the volume equation, but I'm expressing it in terms of how the height of this pile is changing. The derivative on the left side becomes df dt. On the other side, I'm going to bring that 3 down. I'm using the power rule. 12 pi h squared. I dropped down the 3 times 1, and I subtracted 1 from the power. I just used the power rule there. And then I took the derivative of something involving h with respect to t. So this is dh dt. Going back up to our given information, our volume is changing at a rate of 50 cubic feet per minute. So the left side of the equation is 50. I'm also given h. When the pile is 13 feet high, my h is 13. And the thing that I wish to find is the change of height with respect to time, which is this piece that we have there on the right side. So we're going to type some things into a calculator. 3 over 12, that reduces to a quarter. Divide the top and bottom by 3. If I'm looking at 13 squared, that's 169 dh dt. I want to get rid of that quarter, so I can multiply the other side by 4 to do so. 50 times 4 is 200. Pi 169 dh dt. And finally, treating this pi times 169 just as a number that I could divide by, that I'm currently multiplying by, I would get 200 divided by, and then I've got pi 169. That's the change in my height with respect to time. Whatever that number is in a calculator can give me an idea of how that height is changing with respect to time. That was a related rates problem. I look forward to checking out more of these with you soon.